Hey guys, I'm back here at Whitney Labs today with another little critter that I want to introduce you guys to. This is the Horseshoe Crab. So its name is a little bit confusing. Horseshoe crab is not necessarily a crab. It's more closely related to spiders and ticks because they're in the subphylum of Chelicerata, which is a form of arthropod. So they're more closely related to those than they are to crabs actually, so the nickname is a little confusing. But they get their name horseshoe crab because their carapace and shell is in the shape of a horseshoe right there. Woo! These animals are mostly found on the western side of the Atlantic, up and down the east coast, more along those northern states. Horseshoe crabs will eat worms, other invertebrates, and sometimes even fish. While horseshoe crabs don't have teeth to grind up their food, they don't even have jaws. So what they'll do is they'll take their food with their little pincers and they'll put it in their mouth, they'll swallow it, and it goes through a gizzard. And so in this gizzard they put sand, gravel, stone, and that will actually grind up their food for them and make it easier for them to digest. Horseshoe crabs are considered actually living fossils. Not much of their body has changed over the past 400 million years. So these guys were alive during dinosaurs and have been around since. While the blood of humans, when oxygenated, is red, the blood of horseshoe crabs actually, when it meets air, turns cerulean blue, a very bright blue color. The reason their blood turns blue is because it has a copper-containing protein in it called hemocyanin. And that's used basically to bind oxygen to it so it can distribute oxygen throughout its body. So what you're seeing here below the legs are what's called the book gills. Now the book gills is the respiratory system for the horseshoe crab. I'm going to show it again because it went kind of fast. But you see them going up and down there? Looks like pages of a book. Inside each of those appendages are nearly 100 different membranes, and in those membranes is where oxygen is transferred between water and the horseshoe crab's blood. Scary, right? Interesting thing about them is that their blood actually also contains amoebocytes. Those are being used heavily in research now in order to come up with new antibiotics, bacterial testing things. Actually, on the International Space Station, they use a compound derived from the enzymes in horseshoe crab blood to test sterile environments for harmful bacteria and fungi. So parts of these guys have made it even to space. I feel like I'm in the movie Alien. Thank you so much, Whitney Labs, for letting me come out and shoot some of your animals today. I'm actually here at Whitney Lab in their educational outreach department. This is a place where kids can come, K through 12, learn about the scientific method. You can use these microscopes here and learn about all these different forms of ocean wildlife that they deal with here. They learn what it is to be a scientist, and hopefully by the end of the program they end up inspired and want to dedicate their lives to this. I know just from being here for a short time, it is truly amazing the work that they do here. It's so cool to be able to walk through here and see what these kids get to experience whenever they come to Whitney Labs. I wish I had something like this when I was growing up. Whitney Labs actually services more than 5,000 different school children throughout the year. They get to come here, or Whitney Labs goes to them at school, and they teach them about animals, and they teach them about ocean life, and they foster a sense of community and a sense of stewardship for the planet. Thank you, Whitney Labs.